What you're about to hear isn't magic. It isn't a miracle off-grid solution, and it certainly isn't a replacement for your home's electrical system. This video is created purely for educational and historical exploration purposes. Everything discussed here is based on scientific research, historical records, and documented experiments, not guaranteed outcomes. Results will vary depending on your soil type, moisture levels, mineral content, the materials you use, and a dozen other environmental factors. Some of what we explore today goes back centuries. Some of it is being studied in modern labs right now. But none of it should be attempted without understanding your local safety codes. And if you're ever dealing with anything connected to your home's wiring or grid, please consult a licensed electrician. With that said, what you're about to discover might just change the way you look at the ground beneath your feet. Imagine this. You're stranded. No power, no grid, no generator. Just you, the earth under your boots, and a handful of loose change rattling in your pocket. Now imagine someone telling you, right now, that those two things combined could actually generate a measurable electrical current. Sounds impossible, right? Sounds like something out of a survival fantasy or a late-night science fiction show. But here's the thing, it's not fiction, it's electrochemistry. And it's been quietly sitting in plain sight for over 200 years. The real question isn't, can dirt and coins produce electricity? The real question is, why does almost nobody talk about this? And more importantly, could a regular American sitting in their backyard right now actually test this themselves? That's exactly what we're going to break down today. Let's go back, way back. It's 1799. An Italian physicist named Alessandro Volta, yes, the same man the Volt is named after, makes a discovery that would quietly reshape civilization. He stacks alternating discs of zinc and copper, separates them with cloth soaked in salt water, and measures something extraordinary. Electrical current, flowing, steadily, from metal and liquid alone. He called it the voltaic pile. The world called it the first battery. But here's where it gets interesting. Volta's original concept wasn't complicated, it wasn't expensive. It was built from the most basic materials imaginable. 2 different metals and a conductive liquid in between. And soil, moist, mineral-rich soil, is a conductive liquid equivalent. Ancient civilizations across the Middle East and South Asia were documented using clay pots filled with iron rods and copper cylinders, structures that archaeologists now believe may have functioned as primitive galvanic cells. Nobody fully agrees on what they were used for, but the chemistry checks out. And this is where most people stop looking, because somewhere between the Industrial Revolution and the age of lithium-ion batteries, this older, simpler approach became less mainstream. Modern systems overshadowed it, textbooks skimmed past it, and a whole generation grew up never knowing that the ground they walk on every single day carries electrochemical potential. Let's break this down in plain English. When you stick 2 different metals into any conductive material, soil, salt water, lemon juice, even your own sweat, something happens at the atomic level. Electrons start moving. Why? Because different metals have different tendencies to give up electrons. Scientists call this the electrochemical series. Zinc, for example, really wants to release electrons. Copper, on the other hand, is much more reluctant. When you connect them through a conductive medium, that difference in behavior creates a push, a potential difference. And that push is what we call voltage. Now, dry dirt alone does almost nothing. The key variable is moisture and mineral content. Wet soil packed with ions, dissolved salts, minerals, organic compounds can absolutely act as an electrolyte. The same basic principle that powers a lemon battery in a 5th grade science class. Think of it this way. Your standard AA battery has zinc on one end, carbon on the other, and a chemical paste in between. A dirt and coin cell has a zinc-coated coin on one end, copper on the other, and moist soil in between. Same architecture, wildly different scale. The voltage produced is real. Typically, somewhere in the range of 0.5 to 1.5 volts per cell, depending on conditions. The current, the actual flow of electrons, is extremely small. We're talking milliamps. Not enough to charge your phone, not enough to power a light bulb, but enough to measure, enough to prove the concept works. Before we go any further, I want to hear from you. Have you ever tried anything like this? A homemade battery, a survival power experiment? Anything off-grid? Drop your state in the comments right now and tell me what your experience has been. Or just tell me, did you already know this was possible? Because I can tell you, most people who've been gardening for 30 years have no idea the ground they're working in every single day has electrochemical properties. If this kind of forgotten practical knowledge is what you're here for, hit subscribe and make sure notifications are on. We go deep on this channel, not surface level, deep. All right, let's keep going. So what does this actually look like in the real world for a regular American homeowner, prepper, or DIY enthusiast? A basic soil battery also called an earth battery or galvanic soil cell, can be constructed using two different metal electrodes buried in moist ground. Zinc and copper are the most commonly tested combination, largely because they sit far apart on the electrochemical series, which maximizes the voltage difference. Historically, some researchers in the 19th century experimented with earth batteries as a way to power telegraph systems in rural areas where conventional power sources weren't available. The soil provided the electrolyte. The buried metal plates provided the electrode difference, and weak but consistent current flowed. Now, here's the honest reality for modern use. The power output is genuinely tiny. We're not talking about powering your refrigerator, your lights, or even a reliable phone charger. In practical tests, small arrays of soil cells have been used to power low-drain devices. LED indicators, basic sensors, educational demonstrations. Climate matters enormously. Dry climates, sandy soils, or frozen ground dramatically reduce conductivity. The American Midwest and Pacific Northwest, with their naturally moist, mineral-rich soils, tend to produce better results than desert regions like Arizona or Nevada. Soil composition matters too. Clay-heavy soils with high mineral content outperform sandy or rocky ground by a significant margin. And over time, the metals corrode. The zinc electrode especially will degrade as it sacrifices its electrons. This means any real-world setup requires maintenance and periodic electrode replacement. Here's how to test this yourself, safely, simply, and for just a few dollars. You'll need a copper pipe or thick copper wire about 12 inches long, a zinc-coated nail or strip of zinc metal the same length, a basic multimeter available at any hardware store for under $15, and a patch of moist outdoor soil. Push both metal pieces into the ground about 8 to 10 inches apart. Make sure they are not touching each other. The contact would short-circuit the whole experiment before it starts. Connect your multimeter leads, red to the copper, black to the zinc, and set it to DC voltage mode. Then read the display. In reasonably moist, mineral-rich soil, you should see a reading somewhere between 0.3 and 0.9 volts. If your soil is dry, try watering it lightly and waiting 10 minutes. If you see nothing at all, try moving to a different patch of ground, one that looks darker and more organic. To increase output, you can connect multiple cells in series, just like stacking batteries. Each additional pair of electrodes adds to the total voltage. 10 cells in decent soil could theoretically push you toward 5 to 8 volts, though the current remains very limited. One important safety note: this experiment produces extremely low voltages, so there's no shock risk from the cells themselves. The only caution is ensuring you're not near underground utility lines. Always call 811 before digging anywhere in the United States. That's not just advice, it's the law. Let's be completely straight with each other here. This is not a replacement for solar panels. It is not a survivalist power grid you can build in a weekend. And anyone claiming you can power your home with dirt and coins is overstating the science dramatically. What this is a genuine, documented, fascinating intersection of history and electrochemistry that works at a small scale. It's an educational experiment with real measurable results. It's a proof of concept that the Earth itself contains electrochemical energy. Energy that researchers are still exploring for applications like low-power environmental sensors, remote monitoring equipment, and agricultural technology. Some universities are actively studying microbial fuel cells, systems that use bacteria and soil to generate electricity through their natural metabolic processes. This is real, funded science, and it grows directly from the same foundational understanding Volta unlocked over 2 centuries ago. So does dirt and coins produce electricity? Yes, measurably, reproducibly, but don't quit your day job based on it, at least not yet. Here's what I want you to take away from today. The ground under your feet is not just dirt, it's a chemical system. A living, mineral-rich, electrically active environment that our ancestors understood in ways we've largely forgotten, and that modern researchers are only now beginning to fully explore again. There's something almost philosophical about that. We spent 200 years building more and more complex power systems, and the simplest version of the concept was always right there, buried, waiting. Now before you go, everything in this video is for educational and historical exploration only. We are not making any medical, financial, or engineering claims. Results from any DIY experiment will vary based on your soil, your climate, your materials, and your execution. Always follow local safety codes. Always call 811 before digging. And when in doubt, consult a licensed professional. This channel, Fix Fival Secrets, exists to bring you the practical, forgotten, and overlooked knowledge that deserves a second look in the modern world. If today's video made you think differently about something as simple as the dirt in your backyard, then we did our job. Next time, we're going to explore something that connects directly to this. Another method that early American homesteaders used to solve an energy problem that most people today assume requires expensive modern equipment. You're not going to want to miss it. Hit subscribe, drop a comment, and we'll see you in the next one.